All right, so number 2, really it's graphing, looking at everything that we've done before, but let's go ahead and talk through some of this. So you're going to want to go ahead and put this into your calculator. And before you do anything else, you're going to want to go ahead and write the table of values by hitting second graph. That'll give you your table of values. Go ahead and graph the ones you can. But if you notice your max and min, it appears as if they might be at the y-intercept of 0, -3, and it appears as though 2, -5. It's actually not those values. You have to actually use the second trace function of your calculator. So if you press second trace, you're going to want to then find the maximum value. So your maximum value when you do left bound, right bound is going to give you 0.184, -2.911. That's the maximum, and that's going to be right in here. Your minimum is going to be actually right here, and again, you're going to want to do second trace, go to minimum, do your left bound, right bound, and then your minimum is actually going to be 1.816, -5.089, which is going to be right here. So you're going to want to definitely represent those on the graph. Okay, you also have a 0 right here at 3, 0. That's where it crosses the x-axis or the x-intercept. All right, so once you have that nicely graphed, with all of your points represented, your arrows, etc., you're going to go ahead over to your properties. So your domain is going to go from -infinity to infinity. Polynomial functions have that domain. Your range values, this keeps going down and keeps going up. So your range values are also all real numbers from -infinity to infinity. It's continuous. Your x-intercept is 3 right here. Here's your x-intercept. Your y-intercept is -3 right here where it crosses the y-axis. Now your end behavior, as x goes to -infinity, so x going to -infinity is going from here to -infinity. So that's really the left side of your graph. So what is the left side of your graph doing? It's going down to -infinity. And then what is the right side of your graph going? As x goes to +infinity, that's the right side. The right side of the graph is going up to +infinity. Local min, here it is right here. You use the y value of your local min, which is -5.089. Your local max, you're going to use the y value of the maximum, -2.911. Since it keeps going up and down, it's none. Notice again your range goes from -infinity to infinity. You can't have those as absolute mins and maxes. Infinity is not an absolute max or min, so therefore none. Your increasing intervals go from here, which is -infinity, up to the vertex here. Let me make that a little smaller. And then from here all the way up, a little bit too small, let's make it a little bit more. From here all the way up to +infinity. So those are your two intervals from -infinity, and again you want to use the x value of the max and min because you increase from left to right, which is the x-axis, so you use the x value. Okay. Now your decreasing interval is only right in here, so it only goes from here to here. That's your decreasing interval. So your decreasing interval goes from the x value of the max to the x value of the min. All right, solutions. Solutions are x cubed minus 3x squared plus x minus 3. This means that it is a third degree polynomial, which means it has 3 total solutions. Again, these two always match. Okay. Number of real is how many times it crosses the x-axis. Crosses the x-axis 1 time, which is right here. That means that I have 2 imaginary, so 3 minus 1 is 2. What is the real solution? The real solution is actually 3 here because it crosses the x-axis at 3. So your real solution is 3. So now to find the other solutions, I'm going to have to divide 3 out using synthetic division. Here's my synthetic division right here. Done that many times. Then I'm left with 1, 0, and 1 for a equals 1, b equals 0, c equals 1. Plug it into the quadratic formula. Again, the 0 goes away. I really don't need that. 0 squared is 0, so I'm really just left with this plus or minus. Here's my plus or minus. It didn't go anywhere. The square root of -4. The square root of -4 is 2i. So plus or minus 2i over 2, which is just plus or minus I. So there are my imaginary solutions, plus or minus I. Now I'm going to write those as a product of linear factors. So my real solution is 3, so I write it as x minus 3. Then I write x plus I and x minus I.